All right, welcome back. 11.1 Permutations Part 2. Investigating factorial notation. Here's the mathematical definition, factorial. This is a quick way with mathematical notation to simplify the calculations that we do when we're using either the fundamental counting principle, doing permutations. You'll see when we do combinations in the next lesson. And when we do the final lesson, binomial theorem, factorial notation speeds things up quite a bit. So here is the definition for any positive integer n. The product of all the positive integers up to and including n. The notation is n, and that's like an exclamation point right there. And it tells you to do a certain operation. So n factorial. So when it says n exclamation, that's n factorial equals n times n minus 1 times n minus 2 dot 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 times 3 times 2 times 1, where n is an element of natural numbers. If n equals 4, then 4 factorial equals 4 times 3 times 2 times 1. And then when you evaluate that, that is 24. Okay, 0 is defined as 1 factor. Sorry, 0 factorial is defined as 1. Okay. Okay. Without using a calculator, determine the value of 5 factorial. Let's do this. 5 times 4 times 3 times 2 times 1. Okay, that's 20 times 3 is 60 times 2 is 120. 4 factorial times 2 factorial. So we can do operations with factorials. 4 times 3 times 2 times 1 times 2 times 1. 4 times 3 is 12 and 2 is 24 times 2 is 48. Okay, complete the following statement. So another way to look at factorials is, let's write them like this. So 15 factorial is 15 times, you can do times 14 times 13 times 12 on and on, or we can just stop and say 15 times 14 factorial. 10 factorial, likewise, 10 times 9 times 8 times 7 factorial. We can stop wherever we want with the factorial. Write 5 factorial in 3 different ways. So, okay, there's one way. There's another way. 5 times 4 factorial. Okay, one more way. 5 times 4 times 3 times 2 factorial. Okay, number 4. Simplify 8 factorial divided by 6 factorial, so more operations without using a calculator. This is very useful. So if I look at this longhand, that's like saying 8 times 7 times 6 times 5 times, oh my goodness, lots of writing, right? Divided by 6 times 5 times 4 times, this is too much writing, folks, but just stay with me. All these cancel the 1, and you're left with 8 times 7, which is 56. Quick way to do it, 8 times 7 times 6 factorial divided by 6 factorial. There's your cancellation to 1, and then we have 56. So do it this way, folks. Number 5, express the following as a quotient of factorials. So if I have 7 times 6 times 5, how do I get there? Well, if I have 7 factorial over 4 factorial, I think of it this way. 7 times 6 times 5 times 4 factorial divided by 4 factorial. Those cancel. I'm left with 7 times 6 times 5. Okay, just like I said yesterday, or the other day. Let's do one more. Use your calculator to evaluate 13 factorial. So this is very important. Whether you have a TI 8384 or a Casio, you need to know how to do probability functions. So 13 factorial on a calculator, that equals 6,227,020,800. Okay, so I'm going to assume that prior to this lesson, you figure out how to use your calculator to do factorials, because this will be very important in the end. Okay. One last thing, why does 0 factorial equal 1? Okay, we said that is one of the factorial identities. So in general, we know this is the definition of a factorial. We can rewrite this as n factorial equals n times n minus 1 factorial. let n equals 1. So 1 factorial equals 1 times 1 minus 1 factorial. Well, 1 factorial is just 1. 1 is just 1. So this ends up being 0 factorial. Okay, so we get the identity that 1 equals 0 factorial. So that's why 1 is equal to 0 factorial. Okay. Next page. Startup. In how many ways can a teacher seat 4 girls and 3 boys in a row of 7 seats if a boy must be seated at the end of each row? Solve using the fundamental counting principle. And then we'll solve it using some factorial notation. Okay. 4 girls, 3 boys in a row of 7 seats. 1, 2, 3, 4, 5, 6, 7. Okay. If a boy must be seated at the end of each row. I have 3 boys. So that must be a boy, and that must be a boy. The ends. How many boys do I have to start? I have 3, so I have 3 choices for the first end, and then I have 2 remaining choices for the other end. Okay, what about all these middle seats? No restrictions. Okay, I can seat a boy or a girl there, provided that they haven't been seated already. So if I've already seated 2 boys, so I have 7 total, minus 2 boys, that's 5 left, right? So 5, 4, 3, 2, 1, right? Because once I seat one, I can't reseat them, so I can't like repeat seat them, right? So one way to think about this is 3 times, well, this whole middle part here, that's 5 factorial times 2. That's one way to shorten your calculation, so 720 ways. Okay, permutation. We talked about this. Basic definition. Let's get more detail. The arrangement of objects or people in a line is called a linear permutation. That's what we're doing in this unit. In a permutation, here's the key. Order. Star, star, star. Order of the objects is important. When the objects are distinguishable from one another, like a boy or a girl, or an ace of spades or a king, a new order of objects creates a new permutation. Here's the notation. It looks like you're saying NPR. Okay, is used to represent the number of permutations or arrangements in a definite order. So NPR, when you say this, don't say NPR. The way you say this is permutation of n things taken R at a time. Okay, and then a formula for this format, n things, permutation of n things taken R at a time is, here it is, n factorial divided by, in brackets, n minus R factorial, where n is an element of natural numbers. Here we go. The expectation before you come to class is that you know how to do permutation operations through your probability functions on your calculators. Okay, so let's do a couple examples. Determine the number of 4-letter arrangements that can be formed from the letters of the word frosty if any letter can be in any position. Use your calculator and permutation notation to solve. Verify with factorial notation. Okay, I want 4-letter arrangements. So that means my R equals 4. Okay. Frosty has how many letters? 6 letters. So n equals 6. So this is a permutation of 6 things taken 4 at a time. So 6 letters, 6 things taken 4 at a time. I'm making these 4-letter arrangements. Okay, so that equals, let's write it out, 6 factorial over 6 minus 4 factorial. That's 6 factorial over 2 factorial. Okay, I can cancel that, and I'm getting 360 ways. Note that you can just punch this straight into your calculator, and you will get 360. Okay, verify. 5 factorial minus 3 factorial equals 19 times 3 factorial using exact value, so no calculator. How do we solve this using exact value? So let's think about rewriting the first part as 5 times 4 times 3 factorial minus 3 factorial equals 19 times 3 factorial. Okay, so we can do operations on factorials without expanding them using our usual, the rules of mathematics that we know. I can factor out a 3 factorial. That's 5 times 4 minus 1. Okay, that's the key part here. And then inside the brackets, that's 20 minus 1 is 19. And that most certainly equals 19 times 3 factorial. Okay, so left side equals right side, and check. Okay, verify that the permutation of 5 things taken 3 at a time equals 60. Well, let's write it out using the formula. 5 factorial over 5 minus 3 factorial equals 60. Well, let's take a look. 5 times 4, oops, hang on. Okay, I have 5 factorial over 2 factorial. Let's do this without a calculator. And that indeed equals 60. Okay, so that checks. Value at n for n permutation of n things taken 2 at a time equals 56. So no problem. We have a variable. What do we do here? We have n factorial over n minus 2. Oops. N minus 2 factorial equals 56. So we got to see what value of n, right? So we evaluate for n. So how do we do this? So think about our factorial notations. N times n minus 1 times n minus 2 factorial over n minus 2 factorial equals 56. Well, we can cancel those to 1. And we just have a nice little quadratic to solve. Okay. I'm going to ignore that. Remember, I need natural numbers. N must be an element of natural numbers. So I'm going to ignore the negative 1. And I have n equals 8. And on your calculator, if you check the permutation of 8 things taken 2 at a time, it does indeed equal 56. Okay, next page, folks. All right, one of these types, algebraically solving problems. So algebraically solve n if the permutation of n things taken 4 at a time equals 8 times the permutation of n minus 1 things taken 3 at a time. So let's rewrite this. N factorial over n minus 4 factorial equals 8 times n minus 1 factorial divided by n minus 1 minus 3 factorial. Okay, let's do a little cleaning up here. Let's do this for now. Let's see where we go. Leave the left side alone. So we got n minus 4 factorial if I multiply both sides by n minus 4 factorial, so this is what I mean, n minus 4 factorial, oops, okay, what happens? Cancel, 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 cancel. Right, so I'm doing the same thing to both sides. What do I have left on the left side? N factorial equals, oh, look at that, nice and clean so far. Okay, got to deal with this. Left side, let's expand it. N times n minus 1 factorial equals 8 times n minus 1 factorial. I can divide out both sides, n minus 1 factorial. I'm left with n equals 8. And like good equation solving, I'm going to check n equals 8. I have 8 P4, so permutation of 8 things, take it 4 at a time. Does it equal 8 times 8 minus 1 P3? Okay, if you do this on your calculator, let me do this on mine. So permutation of 8 things taken 4 at a time, that equals 1,680. Let's do the permutation of 7 things taken 3 at a time. That's 210. 8 times 210. That's 1680. Check.